Welcome to Alpha Generation channel. We are going to talk about how to solve problems involving bearing and distance. But before we go into this, there are some topics you need to understand very well for you to be able to solve bearing and what? Distance. Quickly, let's look at some of the topics you need to understand before going into this. Number one, I have alternate angles. Alternate angles. When you have two or more parallel lines and have a line that passes through them, we say that this angle here is alternate to this one here and they are equal. So you must understand this. If here is angle A and here is angle B, you can say that angle A is equal to angle B. They are alternate angles. The second one you need to understand is what? Triangles. So if you have a triangle and you are taking here as your angle A, this side facing angle A will be your small a, representing side. A represents angle, small a represents side. Here is B, here is angle B, here is C, here is angle C, and here is what? Side C. So B, side B, angle A, side A, angle C, side C. You need to understand this. The third one we are going to look at is the sine rule. The sine rule. So we are going to look at the sine rule. The sine rule. So this sine rule states that sine A over small a is equal to sine B over small b and is equal to sine C over small c. Or you can state it like this: A over sine A is equal to B over sine B and is equal to C over sine C. So you need to understand this rule and its application. When do we use this rule? If you have a triangle, for you to use this rule, if here is A, angle A, and if here is side A, right? This angle must be given and this side must be given for you to use the sine rule. One angle and one side opposite to each other must be given for you to use the sine rule. Otherwise, you cannot use the sine rule. One angle and one side must be given. So you can use it to find either one angle, an unknown side, or a known side and an unknown angle. So you must know how to use this to solve problems on bearing. The next one we are going to look at is the cosine rule. The cosine rule. So for the cosine rule, we have A representing side is equal to B squared plus C squared minus 2BC cos A. That is for finding sine A. B squared is equal to C squared A squared plus C squared minus 2AC cos B. For finding sine B, so you can say C squared is equal to A squared plus B squared minus 2AB cos C. For finding sine what? C. So when do we use the cosine rule? You use the cosine rule when two sides and the angle between these two sides are given. So anytime you have something like this, anytime you have a triangle like this where two sides and one angle between the two sides are given, you must fall back to this rule. So take note of that and understand it. So you are going to understand this before we go into this. That is for the cosine rule. Now the next one we are going to look at is the four cardinal points. The four cardinal points and how to represent angles on the four cardinal points. The four cardinal points. Four cardinal points. Four cardinal points and how to represent angles on the four cardinal points. So I have something like this. So this is north, east, south, and what? West. This is the 4 cardinal points. The 4 cardinal points. So each cardinal point represents, has an angle of what? We have an angle of 90 degrees. So this is 90 degrees. So this angle here is also 90 degrees, making a total of what? 180 degrees. So this one is another 90 degrees, making a total of what? 270 degrees. This one is another 90 degrees, making a total of what? 360 degrees. So when you sum everything here, it will now give you angle at a point, which is what? 360 degrees. Now, how do we represent angles on this? How to represent angles on this? Representation of angles on the cardinal points. How do you represent angle on this? The first one we are going to look at is 060 degrees. How do you represent it on a cardinal point? So we want to represent 060 degrees. This is the north. Any angle, this first quadrant, okay, before we go into this, let me explain this. Back to the cardinal point. So this first cardinal point can take 0 degrees to 90 degrees only. The first cardinal point is allowed to take 0 degrees to what? 90 degrees only. The second one we take 90 degrees, anything from 90 to 180 degrees. We enter here, right? So the third one we take anything from 180 degrees to what? 270 degrees. It's only permitted to enter here, right? So this one we take a maximum of 270 degrees to 360 degrees. We enter here. So if we want to represent 060 degrees, these 3 digits, angle, we want to represent it here. This is how it will look like. Now to represent angle 60 degrees on your cardinal point, you will take, starting from the north. Remember we said that this first cardinal point will take what? 0 to what? 90 degrees. So 60 degrees. So this is 060 degrees. So that is what? 60 degrees. So here, what you have left here is 30 degrees. So this is how to represent 60 degrees on a cardinal point. It must pass through the what? The first cardinal point. Now let's look at the second one. Let's represent 125 degrees. 125 degrees. Or 120 degrees. So to represent 120 degrees, remember that this place we take 90 degrees. 90 minus 120 will give us what? 30 degrees. So the remaining 30 degrees, we enter the second cardinal point. So this place we take 90, and this one we take what? 30. So that when you add everything here, you have your what? 120 degrees. So I do advise my students to always take it bit by bit, so that you will see how the movement of the what? Angles on the cardinal point. I don't advise my students to just draw 120 degrees from here to here. I always tell them to take the 90 degrees first. Now the remaining angle, which is 30 degrees, will now enter the what? The second cardinal point. So the next one we are going to represent is what? 225 degrees. 225 degrees. So we have this, north, 90 we take, 90 we take. We have what? 180. So we have 90 for the first cardinal point, 90 for the second cardinal point. Now what we have left is 180 minus 225 will give us what? 45 degrees left. So the 45 degrees will enter the third cardinal point. So so that when you add everything from here to here, you have your what? 225 degrees, right? So the next one we are going to represent is 330 degrees. 330 degrees. So 330, we have 90, starting from the north. We have 90, we have 90, another 90, another 90. So what do we have left? 60 degrees. So the 60 degrees will pass through here. So you have 60 degrees. So when you add everything up to this, you have your what? 330 degrees. So this is how to represent angles on the 4 cardinal points. So let's go to our first problem. Let's go to our first problem. Okay, now this is our first example. Our first example, they say if the bearing of A from B, B is your starting point, and from B you travel 330 degrees to meet what? A. All right, so solution. Our starting point is from B. So I'm going to represent this 330 degrees on this cardinal point. Right? Remember what I explained earlier, that this place will take 90, this place will take another 90, making it 180. This place will take another 90, making it 270. That means we have what? 60 degrees left. So 60 degrees left. Can you see it? So this is our B, our starting point B, and this is what? Point A, right? So remember our alternate angle. If I draw this and this, I have a straight line. This line is parallel to this line. So this angle here is alternate to this one here, right? So if here is 60, here automatically is what? 60 degrees. Alternate angles. A, B. So this angle is equal to this angle. Therefore, this angle here is alternate to this one here. They are equal, right? So now the bearing of B from A. The bearing of B from A is, you start from the north. You calculate everything that you have here, starting from the north. Always start calculating your angles from the north. So you have 90 plus 60. So therefore, bearing of B from A is equal to this angle 90 plus this one. You cannot exceed this line because this is the line that will take you back towards B. So you stop at this. So plus what? 60 will give us what? 150 degrees. 150 degrees. All right. This is our example 2. We want to solve the second problem. Now, they say the bearing of Q from P is 150 degrees. And bearing of P from R is what? 015 degrees. If R and Q are 24 kilometers and 32 kilometers respectively from P, they say we should represent the information in a diagram. Calculate the distance between Q and R. Find the bearing of R from Q. All right? So, now the first thing we're going to do is start with this. Now, the first angle we have is what? 150 degrees. 150 degrees, automatically we enter the second cardinal point. Right? Our starting point from P. P is our starting point. So, from P, we are going to move 150 degrees. Right? So, this is what we have here. This is point P. Starting from the north. Let me make it a bit bolder. P. This is the north. Starting from the north, we want to move at angle 150 degrees to Q. This is 90 degrees. The first cardinal point we take 90 degrees. Now, when you take 90 from 150, you have what? 30 degrees, 60 degrees left. So this is 90, and this is what? 60. You have entered the what? the second cardinal point, so that the total will give you what? 150 degrees. Please always remember to take your angle bit by bit. The first cardinal point we take 90. Whatever you have left, we go into order the next what? Cardinal point to the next until you have your what? Angle. So from here we move towards Q. They say from P we move towards Q, right? From P we move towards Q. So this is our point Q. So this is our point Q. Now let's say R from, okay, bearing of P from R is what? 15 degrees. 015 degrees means 15 degrees, right? So you are going to look for a perfect position so that you can move 15 degrees back to Q. And I think the position is around here. So to travel 15 degrees, you must be somewhere around here to travel 15 degrees. So from here, I can even bring it closer. I can travel what? 15 degrees. 015 degrees. Right? Taking? Okay. Now, another thing you need to pay close attention to is the distance. They say that, look at the distance, that R and Q. R is 24 kilometers away from what? P. And Q is 32 kilometers away from P. It means that 32 must be longer than what? R. Q must be longer than R, because Q here is 32 kilometers. And it's longer. So let us remove this angle here and put it here. 015 degrees. So this is our R. Now, Q is 24 kilometers away. Can you see it? So you must maintain this, because if you don't do it like this, it's going to affect your angles, the position of your angles, especially when you're asked to find the what? The bearing. It will affect it. So take note of the distance. You can see that this one is longer than this one. So you cannot join this point and this point. Right? Now remember back to our alternate angles. So you have a straight line like this. We say that this angle here is alternate to this one here. Alternate angle. So we are going to apply it here. If here is 015 degrees, automatically here will be what? 15 degrees. So remember, each quadrant represents 90 degrees. So if here is 60, what do you have left? 30. You put it here. So that the whole of this angle will give us what? 45 degrees. Right? Now, we go back to the leveling of triangle. So if you have something like this, remember, if here is P, here automatically will be small p. If here is what? Q, here will be small q. And if here is R, here will be what? Small r. Remember the leveling of this triangle. So that this place now is P, the side facing P is our small p. And that is the distance they are looking for. They say that calculate the distance between Q and R. Q and R. The distance between Q and R is our small p. Right? The distance between P and R is our small q. And the distance between P and Q is our what? Small q. Right? Okay. Now, if you look at the triangle here, let me show you the triangle. We have 45 degrees here, and here is 32, and here is what? 24. What rule do you think is applicable to this problem? I know you remember the cosine rule, because you have two sides and the included angle, or the angle between the two sides are given. So this is what? The cosine rule. All right? So we are going to use the cosine rule, saying that p square is equal to r square plus q square minus 2rq cos p. You can say q square plus r square minus 2qr. No problem. It's still the same thing, right? So this will give us what? 24 square What is our R? Okay, our R is 32 square plus our Q, 24 minus 2 times 32 times 24 cos 45 degrees, right? So without wasting your time, I'll just look at, if you square 24, you get 576 plus, you square your 32, right? If you square your 32, you get what? 1024 minus everything here will give us 1086. So this times this times this times cos 45 will give us what? 1086. So if you add this and subtract 1086 from it, you have 514. 514. So our p square is equal to what? 514. So you take the square root of both sides. This will now be square root of 514, which will give us what? 22.67. If you take the square root of this, you get what? Approximately, we have 22.67, so approximately 22.7 kilometers. 22.7 kilometers. Therefore, the distance between QR is what? The distance between Q and R is what? Approximately 23 kilometers. 23 kilometers, right? So that's how to solve the problem. Now, we can easily go to, they say find the bearing of R from Q. The bearing of R from Q. So you're going to perform your calculation here, Q, right? Okay. So I'm going to clean this one now and show you how to find the bearing of any point. The bearing of R from Q. From means your calculation will be based on Q. Your calculation will be based on what? Q. So quickly, let's look at how to find the bearing of R, from this point, right? Okay. Now, for us to find the bearing of R from Q, this is what they're looking for. They're looking for this angle plus this angle plus this angle, then plus this small angle. You cannot exceed this line because this is the line that will take you back to R. You cannot exceed this line because remember the bearing of R from Q. So this is the line that will take you back to R. So you calculate everything starting from the north down to this place plus this angle. So for us to do that, we need to know the value of this angle theta, right? So if you look at the triangle, it is like this. If you look at the triangle, it is like this, right? So here is 45, here is 22.7, here is 24, here is 32, right? So now we have one angle and one side facing each other. That means we can use this cosine rule to find this angle theta here. To find this angle here, we can use the sine rule. Sine rule says that when one angle and one side are facing each other, that you can use the sine rule. So we can use the sine rule to find angle what? Theta. So quickly, let's look at the sine rule. So we can say sine P over 22.7. Remember, sine P is 45 degrees, is equal to sine Q over small q, which is 24 kilometers. Right? So this which is what? 24 kilometers. So if we solve this, or if we make the subject of the formula here, we have cross multiplication now, this times this, then this times this. So this is sine theta is equal to 24 times sine 45 divided by 22.7, right? So now if you perform everything here, if you use your calculator to look for sine 45, right? To look for sine 45, multiply by 24 divided by 27, everything will give you what? 0.7476. 0.7476 will give you what? Sine theta. So theta is equal to the sine inverse of 0.7476, right? So theta, now take your calculator and look for the sine inverse of 0.7476. This will give us what? 48 degrees. 48 what? Degrees. So this is telling us that this angle here, theta, is equal to 48 degrees. This angle here is 48 degrees. Remember that this angle is 30. It's alternate to this one, which is what? 30. So if here is 30 and here is 48, what do we have left? Remember we said that each quadrant represents what? Represents 90 degrees. So the whole of this angle is supposed to be 90 degrees. But from here to here is 30 plus 48, which will give us what? 78 degrees. We have what left? 12 degrees left. So that 12 degrees will be here. So this angle now is what? 12 degrees. 12 degrees. This angle is 12 degrees. So the bearing of R from Q bearing of R from Q is equal to first cardinal point 90. Always start from the north. First cardinal point 90, second cardinal point 90, third cardinal point 90, plus this angle, because you cannot exceed this angle, because this is the line that will take you to what? R. This line will take you back to what? R. So plus this angle, 12. So which is equal to what? Everything here, if you sum everything, 90 plus 90 plus 90 will give us what? 282 degrees. 282 degrees. Very simple. Did you get it? So this is how to solve problems involving bearing and what? Distance. I hope you have been able to master this topic. So we are going to solve more on this. So subscribe to our channel, and by the grace of God, we are going to supply more videos on how to solve this problem and so many other problems in what? Mathematics, using simple and straightforward what? Steps. Thank you. Remember to like our page and remember to subscribe to our channel. See you soon.